equations reducible to the linear form. So there is an example. If we consider this xy times dy by dx, xy minus dy by dx equals y to the power 3 times e to the power minus x squared. So if we consider this times dy by dx is there, right? Xy is also correct, but if we consider the right hand side, what happened? Y term is there. So we know that this part is if we consider that, so we will take this and descriptively do. So we goes to here, then that example we take, that is xy minus dy by dx equals y to the power 3 ex squared. Our general equation is dy by dx plus py equals q, right? P is there, doesn't matter, right? Here plus sign, it means we have to multiply this by minus, then here come plus, that's no matter, then here come minus. But here q is this whole part, that is equals e to the power minus x squared plus y to the power 3. When we define this, we call this also function of y, sorry, function of x, but not in function of y, no. So but here y terms are there, so that is not a linear differential equations, but our topic is equations reducible to the linear form. So it means we can reduce this equation for the linear form. You know that here what is additional term is there, y cube, no? So we can divide by y to the power 3. We will see what happened there, right? So right, if we divide y to the power 3, here come minus x over y squared, no, sorry, here not minus, here plus, no, minus 1 over y cube times dy by dx. I am dividing whole equation by y squared equals e to the power minus x squared, right? But it is not in this, not still in linear form. Why? Because now what happened, then y term is comes to here, then this is not the function of x. Now I am going to do take z equals 1 over y to the power 2, right? I am taking this. If I take this z equals that, then I am going to find dy by dx. So then y to the power 2 equals 1 over z, no? If I am taking z equals y to the power 2, then y to the power 2 equals 1 over z, then I am 2y times dy by dx equals ln z times, sorry, 1 over z, no, I am integrating, no, not integrating, I am differentiating. This is z to the power minus 1, it means 1 over z square times dz over dx. I differentiate that. Now I am going to, here we have minus dy by dx, no? So I am subject minus dy by dx, right? Because minus dy by dx is there, equals 1 over z means 1 over y squared. So I am right 1 over y squared to the power 2. 1 over z, this 2y is come for there, then 1 over 2y times dz over dx, right? So then what we can do is minus dy by dx equals 1 over y squared is, then y to the power 4 is there, y to the power 4 is there, 1 over 2y dz over dx. Y cube is remaining, right? So I am sending this y cube for that side, then minus 1 over y cube I send this side times dy by dx equals here remaining half times dz over dx. So instead of this term, now we can substitute that one, right? So I take z equals 1 over y squared. So here we can write x multiplied by 1 over y squared, no, minus 1 over y to the power 3 plus dy by dx, right? So then next 1 over y means x times z, I substitute here, and instead of this term we can write plus 1 over half times dz over dx equals e to the power minus x squared. Now I can multiply whole equation by 2, then it's come 2xz plus dz over dx equals e to the power minus x squared. So I can rearrange this dz over dx plus 2xz equals e to the power minus x squared. So you can see now this is linear equation, no? So we can write this is a linear equation of the form what is form dz over dx plus p of x, now we said equals q of x, no, where px equals 2x and qx equals e to the power minus x squared. Now we can find the integrating factor. To that we have to find integration of p of x dx equals 2x times dx, that is equals x squared over 2 times 2 equals x squared. So integrating factor then e to the power minus integration of p dx equals e to the power x squared. Now we found the integrating factor as x squared. Now what we have to do is we have to multiply whole equation by integrating factor, then e x to the power 2 times dz over dx plus 2 e to the power 2x x z equals here e to the power minus x squared, here e to the power plus x squared. What happened? Answer is 1 here. So then we can write this is reduced into that form d over dx times ex squared over, no, now that is not y, now it is z. So we will see our answer is correct. E to the power x squared times dz over dx, it is there, z times integration of differentiation of this e to the power x squared times 2x, yes, that is correct. Then we can separate the variables and integrate this dx, right? Then e x to the power 2 times z equals x plus c, where sorry, one mistake is done there, no, yeah, I multiply this equation by 2, so 2x, then it is come 1, then here 2ex, yes, 2ex, right? And so where then here come, that is not 1 2, there 2, then here 2x, here 2 times dx, 2x plus 3. Now it's correct. But the mistake is I am not multiplied right handed side by 2, right? Then now I can subject sorry, now z we took z equals 1 over y squared, no, so then but z equals 1 over y squared. Z equals 1 over y squared, right? So then we can substitute e to the power e x to the power 2 equals z equals 1 over y squared equals 2x plus c, where c is an arbitrary constant. We have to write this. So then I can subject y is here, y squared is there. If I subject y squared, then it is come ex to the power 2 over 2x plus c, right? Then I can take y equals plus or minus square root of ex to the power 2 over 2x plus c. We can write this y equals plus or minus e, this is half, no, x square half over 2x plus c. This is the answer, right, where c is an arbitrary constant. Yes. We got this answer, no? Yes, y equals plus or minus e half x squared over square root of 2x plus 3. So if a given equation is in that form, it means in this form there is a power of y in the right hand side. We call that equation is in the form dy by dx plus py equals q times y to the power n. Here the additional term is by considered with the linear differential equations, there is one additional term in the right hand side, that is y to the power n. If we see this type of equation, we call that is a Bernoulli equation, right? So here the same thing, p and q are the functions of x. So then above equation, it means this equation also the Bernoulli equation. So if we have the Bernoulli equations, now we got this z equals y squared, but you don't know why we use z equals y squared. There is a general case if we have the Bernoulli equations, right? Bernoulli equation. Bernoulli equation. Bernoulli equation means this form dy by dx plus py equals q. Then additionally we have y to the power n. This is a Bernoulli equation here also, where p and q are functions of x but not y, right? But not y. So we can reduce this to by using this substitution, z equals y to the power 1 over 1 minus n. This is the substitution. Then here also we use the same substitution, right? So yes, I will show you, right? This is the given equation. Equation is, I'm using a separate color now, xy minus dy by dx equals e to the power minus x squared times y. But so I am multiplying this by minus sign, then it's come plus dy by dx minus 1, then minus xy. Here also minus e to the power x squared times y to the power 3 is there, right? Now this is a Bernoulli equation of the form, what is the form, dy by dx plus py equals q times y to the power n, where p equals minus x and q equals minus e to the power x squared and n equals 3. Here y to the power n equals 3, right? So we know that our substitution, if it is a Bernoulli equation, what is the substitution? Z equals y to the power 1 minus n. So then here substitution, z equals y to the power 1 minus n. Z equals y to the power 1 minus n. N equals 3. 1 minus 3. Z equals y to the power minus 2. It means z equals 1 over y squared, right? That's why we used y squared in there. Z equals 1 over y squared. I think now you have understanding how we take the substitution it take first you have to check whether it given the equation is Bernoulli equation or not. Then if it is a Bernoulli equation, what you have to do is you have to use this substitution z equals 1 over y to the power 1 minus n. Then you have to find the dy by dx and dz by dx. So then you have to substitute this, and you then it is reduced for the linear differential equation. After that you can solve this and take the value for the y, right? That thing you have to do if it is a Bernoulli equation, right? Then we can consider another example, right? Example 2, right? Example 2, 2x minus 10 y to the power 3 times dy by dx plus y equals 0. So now we can consider that example. Example 2, that is 10x minus 10y power to the power 3 plus dy by dx plus y equals 0. This is not a linear differential equation, as well as this is not a Bernoulli equation. That now what we have to do is, so we have to do some changes for this equation, and we have to convert this for equation which we are known. For our known form, first we have to convert this equation. So to do this, I am multiplying equation by dx over dy, right? I multiply whole equation by dx over dy. Then what happened here? Here remaining only 2x minus 10 to the 10 y to the power 3. Then here 1. Then y times dx over dy equals 0. Now I am sending for that side. Then y times dx over dy plus 2x equals 10 y to the power 3. Then I am dividing whole equation by y. Then dx over dy plus 2x over y equals 10 y to the power 2. I divided whole equation by 1. Now what happened there? This is equation by our known form, that is a linear differential equation, but there is a difference. What is the difference is, now this is the independent variable here is not x, that is y in there, right? So we can write this is a linear differential equation with independent variable y, right? This is not, now this is not the independent, now independent variable is not x, that is y. Okay, now we can comparing with general form. Now we have to do a little bit of difference in our general form. Earlier we used dy by dx, now we have to use dx by dx plus p of y, no, then not x, because that is, now it should be the function of y, because that is the independent variable is y, then this should be function of y. Yes, that is correct. This is function of y and this is function of x, right? Okay, so now what you have to do is we can write, then here p equals 2x and sorry, not 2x, now we have to take y, no, that is 2 over y. P equals 2 over y and q equals 10y to the power 2, no, right? Now we have to find the integrating factor. Now we need to find p dy, not dx. Now our differential independent variable is different. Then 2 integration of 1 over y times dy, that is 2 times ln y, then integrating factor e to the power minus p, integrating factor e to the power py times dy equals, we found p dy is equals e to the power ln y, 2 ln y, so we can write this e to the power ln y to the power 2, we can send for this here, no, then y squared, then e to the power ln means then it's come as y squared. So our integrating factor is y squared now. Then multiplying by integrating factor, whole equation we have to multiply it by integrating factor. So what is our equation? Dx by dy, then y squared times dx by dy, y squared times dx by dy plus y squared, if we multiplied y squared it's come 2xy, here 2xy equals y squared 10 y squared, it means 10 y to the power 4, here 2xy 10 y to the power 4 here, right. Then we can write this d over dy times y square times x equals 10 y to the power 4. We'll see our answer is correct or wrong. Y squared times dx by dy, yes, correct. Then x times differentiation of y, that is 2y, yes, that's correct. Now we can separate in the variable d times y squared x equals 10 integration y to the power 4 dy. Then here come y squared x equals 10 y to the power 5 over 5 plus c, where c is an arbitrary constant, right. So now we can subject x, now our dependent variable is x, not y, so we have to subject x equals here 2, no, 2 y to the power 3, I can divide by it, then c y to the power minus 2, this is the answer, right. Yes, we have 2 y to the power 3 plus c y to the power minus 2, we got the answer. Now we discussed about linear differential equations and how we can simplify the linear differential equations by using the integrating factor, and also we consider the Bernoulli equations and the substitution for the Bernoulli equation, and after substituting that and it is also reduced for the linear differential equations, again you can introduce the integrating factor and you can solve this. And also we can class another type of equation which can be reduced for the linear differential equations, but then that example, it means this example, there is a difference because x and y are changed. It means independent variable and dependent variable are different than the other examples. So now I think now you have clear understanding about the integrating factor and linear differential equations, and so also the Bernoulli differential equation, the other form of the equations which can be reduced for the linear differential equations. So if you have any problem you can let me know, and based on this lesson also you have an tutorial, so you have to submit the tutorial within given time. Okay, right, thank you very much.